This video is on solving decimal equations. It's lesson 24 in your book on pages 140 through 145. Now, solving decimal equations is not really any different than solving any other equation. The only different thing that we're going to talk about in this video is how to use a power of 10 to make your equation easier to simplify or easier to solve. Now, here we have an equation. It's 8 plus 0.5x equals 10.5. Now this would be a lot simpler and we could practically do it in our head if we didn't have any decimals here. So we're going to multiply by a power of 10 in order to eliminate some decimals. Now, in order to do that, we're going to count how many decimal places we have in each term. So in 8, we have 0 decimal places. In 0.5x, we have 1 decimal place, and in 10.5, we have 1 decimal place. Now we're going to use 10 to the power of the most decimal places. So since 1 is the most decimal places that any single term has, we're going to multiply each side of this equation by 10 to the first power, or just 10 in this case. Now we can use the distributive property on the left side. 10 times 8, that's easy, that's 80. Now 10 times 0.5, since we're multiplying a decimal by a power of 10, we can move the decimal point that many places to the right. 10 has 1 0, so we move the decimal point 1 place to the right, and we get 5x. And it equals 10.5 times 10, decimal point, again, 1 place to the right, to get 105. Now we can easily solve this just like any other two-step equation. So if it was an expression, we would simplify it by first multiplying 5, and then once we multiplied 5 times x, the next thing we would do would be to add 80. Now to solve the equation, we're going to do opposite operations in the opposite order. So the last thing I said was add 80, so I'm going to do the opposite of that, or subtract 80, for both sides of the equal sign. Now 80 minus 80 is 0, so on the left side I'm just left with 5x. And 105 minus 80 is 25. Taking care of undoing that add 80 step, the next step is multiply by 5. So I'm going to do the opposite and divide by 5, both sides of my equal sign. 5x divided by 5, my 5's cancel, and I'm just left with 1x. And 25 divided by 5 is 5. So the solution to this equation is x equals 5. That means we could plug 5 in for x in our original equation and have a true statement like 10.5 equals 10.5. That example needs to be in your notebook, and also this example, this one right here needs to be in your notebook as well. We're going to try that again, solving by multiplying by a power of 10. So we have our equation here, 0.006a plus 0.02 equals 0.2. We want to figure out which of these terms has the biggest number of decimal places. So this term has 1, 2, 3 decimal places. This one has 2, 1, 2. And this one just has 1. We're going to use the biggest number of decimal places. So we're going to use 3 decimal places. And we're going to multiply each side of this equation by 10 to the third power. 3 because it was the most decimal places. And 10 to the third power is 1,000. So I'm going to multiply each side of this equation by 1,000. Alright, since I'm multiplying by 1,000, I can move my decimal points 3 places to the right, because 1, 2, 3 zeros. So here, 1,000 times 0.006 is 1, 2, 3, and I'm just left with 6a. 0.02 times 1,000, if I move my decimal point 3 places to the right, 1, 2, 3, we assume there's another 0 here, it's 20. And on the right side of my equation, 0.2, if I move my decimal point 3 places to the right, I've got a 2 and then 2 zeros, so 200. Now I'm going to solve this just like any two-step equation. If it was an expression, I would multiply by 6, so that would be my first step, times 6. And then after I multiplied 6 and a, I would add 20. So I'm going to do opposite operations in opposite order. So Instead of adding 20, I'm going to subtract 20 from both sides. That takes care of undoing my adding 20. Bring my 6a down. 20 minus 20 is 0, and 200 minus 20 is 180. So now I have 6a equals 180. Now my next step up was multiply by 6. So I'm going to do the opposite and divide by 6. 6 divided by 6 is 1, and then I've got an a. 180 divided by 6. 18 divided by 6 is 3, and then there's a 0 in there. So a equals 30 is our solution. Alright, now here's another example. Again, this needs to be in your notebook. We can solve decimal equations just the same way that we solve any other equation, so without multiplying by a power of 10 necessarily. That's how we're going to solve this one. So, ignoring the fact that these are decimals, if I knew the value of m, then the first thing I would do to simplify this would be to multiply 0.2 times m. So my first step would be to multiply by 0.2. After I multiplied 0.2 times m, my next step would be to add 0.8. So to solve this equation, I'm going to do opposite operations in the opposite order. My last step was to add 0.8, so my first step is going to be to subtract 0.8. Now I can bring my 0.2 m down. 0.8 minus 0.8 is 0, and 1.8 minus 0.8 is 1. Now I've undone this step. My first step was multiply by 0.2, so I'm going to do the opposite and divide by 0.2. Now 0.2 divided by 0.2 is 1, so on that side I'm just left with m. And 1 divided by 0.2 is 5. So my solution here is m equals 5. Now if I had multiplied this whole equation by 10 to eliminate these decimal places, I still would have gotten m equals 5 as my solution. Alright, here's another example that needs to be in your notebook. We've got negative 0.3n plus 1.2 equals negative 1.44. If I knew the value of n, the first thing I would do would be to multiply n by negative 0.03. So my first step would be times negative 0.03. And after I did that, I would add 1.2. So I'm going to do opposite operations in the opposite order. So this says add 1.2 last, so I'm going to subtract 1.2 first. I can bring down my negative 0.03 n. 1.2 minus 1.2 is 0. And negative 1.44 minus 1.2 is negative 2.64. Now the next step I said was multiply by negative 0.03, so I'm going to divide. I'm going to do the opposite and divide by negative 0.03. Over here I get 1, dividing anything by itself is 1, and then n. Negative 2.64 divided by negative 0.03 gets me 88. So n equals 88. Now if I wanted to know if that worked, I could plug it in for n in the original equation and make sure it was a true statement. Now this example needs to be in your notebook, and it's a little different because here we have to construct the equation ourselves. So it says 0.48 of 86 is what number? Now there's a couple of numbers here that we know we're going to need. We've got 0.48, we've got 86, and here it says what number. Now what number is a hint that we're going to need to use a variable. And it's also got some words that tell us what we need to do, some directional words. Now this says of. Of means multiply. This one says is, and is means equals. So if we're going to turn this into an algebraic expression, we would write 0.48 of, or times, 86 is, or equals, what number, which we would use a variable to describe, like maybe n. Now this one's easy to solve. All we have to do is simplify. 0.48 times 86 is 41.28. So here, 41.28 equals n. And this is our last example that needs to be in your book. It's a zoology application. The height of an average mandrill is 2.54 centimeters more than 12 times the length of its tail. If the height of the mandrill is 78.74, what is the length of its tail? So first let's identify the numbers we need. We've got 2.54 right here. We've got a 12 right here, and we've got a 78.74 right here. Now let's read the question. The height of the mandrill. The height of the mandrill is 78.74. They gave us that later in the problem. Now the next word is. Is tells us we write equals 2.54 centimeters more than. More than is another one of those words that tells us that we need to do something, and in this case more than is add. 12 times is a giveaway. That one means we're going to multiply. The length of its tail. Now the length of its tail is what we're looking for, so that's something that we need also. Alright, so we can turn this into an equation. We can say the height of the mandrill, which is 78.74. Then it says is, so we write equals 2.54 more than. So 2.54 plus 12 times, sorry about that too, the length of its tail. Now, we don't know the length of its tail, that's what we're trying to figure out, so I'm going to call that L. Alright, now I'm going to solve this equation using opposite operations. So if this was just an expression that I was going to simplify, my first step would be to multiply by 12. And once I multiply 12 times L, then my next step would be to add 2.54. So I'm going to do opposite operations in opposite order. So my last step is add 2.54, so my first step in solving the equation is going to be to subtract 2.54. Now 78.74 minus 2.54 is going to give me 76.2. 2.54 minus 2.54 is 0, and so it equals 12L. Now my next step up is multiply by 12, so I'm going to do the opposite and divide by 12. Twelve divided by 12 is 1, so on the right side I'm just going to have 1L, or L. And 76.2 divided by 12 is 6.35. Alright, so that means that the length of this mandrill's tail is 6.35 centimeters. And that is all.